So I have to do this, basically, but worse. Okay, we always need to pass the CPU as the first argument. And then the other two arguments are pointers to Actually, we can simplify this because for now we only have vec helper reg xmm xmm. CPU, 2 pointers. And we're kind of looking at this, where the first pointer is the destination and the second pointer is the source. Wait, does that make sense? We do want to put the RM second. Okay. Sure. But if it's 2 XMMs, it really doesn't matter, does it? Well, does the source go first or the destination go first? I really don't know. I'll have to try both and see, or something. Well, okay. What order would it be in? Reg RM. In the V case, the dest goes first, because the second argument is RM. And then we just index it by reg and then RM. So, XMM first. Wait. If you index it by XMM first, then by XMM, you end up with this, right? Well, okay. Frick. So we only want this for the case of memory. And if it's a register, we need to generate which register. Actually, we always need the which register, but then we might need two registers. Yeah. There's always at least one register, sometimes two. I feel like we could pack them into one 64-bit int, but that's a little bit scary, only a little bit. Because they each go up to 8, right? That's 3 bits for each. You don't need more than 1 byte for that. But for slightly improved simplicity, I'll use 2 bytes. Okay, it's memory involved. We only need 1. There we go. So now the first argument is the helper. The second argument is the XMM index, or the two both combined. So it's little endian, so we just read the byte and then read the next byte. So that's over here. I guess I'm just looking to see what registers are saved and restored that I can use for my own evil purposes. And the answer seems to be basically all of them. Every register is pushed. So I'll use like how's R11? Is that used for anything? CPU, I can't use that. How about R14? That's fine. Or I could just do one load, make it a 16-bit load, and do a bit shift. We kind of need both. So an XMM register is 16 bits, right? So in addition, we do an offset. It's probably going to complain that 16 is not a valid scale. But okay, offsets. Exactly. It has to be 1, 2, 4, or 8. That sucks because XMM registers are 16. So it's like we do have to do a bit shift anyway. I mean, it's cool on ARM how you can just do arbitrary bit field extracts and move arounds, but you can't do it on x86. Gotta use multiple instructions. So I know what we need to do. We need to do it over here. Turn this into a raw byte offset. So if you have the 8th XMM register times the size of an XMM register is 16, I didn't need to type this. You go up to 128, which does fit in a byte, so we go. And then this can be that. And now I pray that it actually works. It does. Well, it doesn't work, but compiles, which is basically the same thing, right? This goes into CX, or DX. Did I say DXKix? That's how I memorize the ABI. Great, we don't need that anymore. I think now we just call it and restore everything. We can leave off the safe regs, actually. Well, no. That's it. How many arguments did we use? 2, okay. Well, that's simple enough. Does it work? Probably not. Actually, you know what? It definitely won't work because it's never used. But, you know, good enough for now. But then we gotta do this guy here. Let's make this into a macro, actually. So, macro helper. This takes names, reg rm. Okay, we definitely need to take the name, and then that goes there. But reg rm, really? Wait, so here you put the rm first? That's kind of confused. So this can start with so we skip these cases. Wait, no, so these can be semicolons because we are in x86 land where things are sane. There we go. Okay. Hey, Chris. Okay, skip that. So the order of arguments is always reg and then rm. Which actually means this is probably wrong. Because the first byte is going to be the rm, and that's going to go into the first argument. We want the reg to be the first argument. So, well, I was trying to be sort of homogeneous here between memory and non-memory, so. But the rm always goes second. There we go. This is insufficiently generic to account for memory, but that's okay. I'll deal with that in a second. So this will be like what is this called now? This is called arg, and then second comes the rm. Actually, no, this gadget list macro has sort of mandates what the gadget has to be called. It has to be called load size underscore arg. And do another one store. And that's that. Oh, we need two arguments. The reg is just arg. The rm is load. There we go. Okay. Now all we need to do is allow for rm to say, okay, this is a memory store, or a memory load, or memory store, whichever. Alright, I should say read and write, though, instead of load and store, because that's just nicer, right? Read, write, prep. I have to say, then I have to give a unique name here. Wait. reg here. So this is just reg helper name. There's the prep, and we need to write done. In this case here. Oh, we forgot the size. But we only need the size if it's read or write. I don't know why I put the size in parentheses. Chris has a little problem. You have to not put colons around the kappa. If you do it right, you will get a kappa. There you go. Right, so now I need to handle that, and the fact that one of the arguments now becomes there's no way to write an if not in, so you gotta work around that. So that in this case, we have an address. Okay, we kind of always need to do that. The first argument is the wait. This should be RM opcode because the RM is now referencing memory. So this is all backwards. And all of a sudden this is backwards too. Frick. Okay, opcode register comes first now. So this is the memory case. And at that point we have an address that we need to pass in as the second argument instead of okay, so by this we've passed in the register as the first argument. Wait a sec. Is everything in the right order in the register case? You have... Okay, so the RM is going to be the destination. So you have the opcode first. And now, so the first argument is going to be the source, which is actually kind of nice. No, 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 no. The RM is always the source. So, okay. We're putting the RM second, right? Yeah, we're putting the RM second in the argument list, which makes no sense. Let's actually change that up. Let's put the RM first. We now have to switch the arguments in every case, right? Wait. Yeah. So the RM goes first. The one that might have to be memory goes first, which is usually the source, but sometimes is the test. Okay, now we've swapped that around. Should we switch this around? Sure, okay. So first comes... Wait, now this doesn't make sense. We're now putting the reg first. For consistency, right? Okay, this is completely meaningless now. Everything was backwards before, and then I switched everything, and now it's still backwards. Okay, we'll do that. So, just kidding. We'll do that. The register comes first for consistency, but then has to go as the second argument. And then the first argument depends. This is one case. And then the other case is memory. Actually, this is way simpler than I was thinking. It's basically just this, right? Okay. Yeah, that's it, right? Okay. I think I'm done. Let's go run Node.js, or at least a tiny amount more Node.js than before. Just kidding. Invalid operand. Oh, dear God, what? Why is this invalid operand? Oh, because there's a D on it. I'm dumb. Never mind. Atraku. Greetings, man. What now? Unexpected token at start of statement. Where? Oh, where I wrote type instead of RM like a moron? Right. What now? Same deal? Did I? Oh, I did it over here. Done. Different error. Yay. I don't know where the fuck I am. I want to set a breakpoint on, like, the gadget that hopefully is triggering. This would be like gadget vec helper. Oh, okay, we're looking at reload, right? So gadget vec helper load 64 XMM. Try it. I guessed it. So what happened? At what point does shit go to hell? Great, now I need to look this up. Let's do that. Perfect. Right, save a bazillion registers, push a bazillion registers, realize that I'm an idiot and well, the helper doesn't always go first. I don't know what happened there. Probably this 2 is wrong. Right, okay, so if we step into this, alright, this is where we want it to be. So, do all this crap. And I think this is where it goes wrong, that we did the wrong amount of ret, because there's one more. Wait, this is always wrong. Wait, okay, so there's one. So in the memory case, there's 2, and in the register case, there's 3. So should do it. Whew. I guess we step through it again. Same breakpoint. Great, so this is apparently where we went wrong. Yeah. Which register do I need to dump right now to see where the instruction pointer was pointing at? R9. I guess we can look and see how many... Okay, so hex 18 means it did pop 3 times, which is wrong. Huh? Yeah, this is wrong. Why didn't it do 2? Actually, wait, no, I'm probably wrong about that. Because gret pops 1 more. Okay, so this did pop twice. How many arguments are there? 1, 2, 3. I got these backwards. Ah! Hi, Milo. Milo? I don't know how to pronounce that. Sorry. This is an improvement! Yay! Alright, what happened? Did I forget to dump the log? Oh, no, I didn't. Oh, this is a page fault now. Great, I have no idea what this means. It probably means that I just did this particular instruction wrong. Nice. Are these arguments in the wrong order or something? Wait. Huh? I don't even know what instruction it is that we're dealing with right here. I think it's time to fire up IDA Pro and like gaze at this shit. Or I could just use obj dump. What do you think? I need to use i686 Linux GNU obj dump on user bin node. Well, I already have an IDB. This is just going to be an assembly language dump of node. That's going to take a moment. IDA might be slightly more helpful here. We have a little problem that now obj dump and IDA is taking up all the CPU that OBS needs to do things. So stream might be a bit choppy. But okay, obj dump is apparently done. And so we have a 2.7 million line dump. If I fire up IDA, it's going to use all of my CPU to just, well, here's IDA. I paused the auto analysis because it really hadn't gotten all that far. I think we'll just look at the obj dump output for now. Great. Where though? I guess we can look at the place where the page fault happened, which was 56DC06A0, which, doing a little bit of math, is A6B6A0. I guess we just have to like scroll. Damn, this is a big file. So space 8 6 B 6 right over here. Okay. A0. It looks like we didn't read the entire instruction in or something, and then it started trying to execute starting at this byte, which would explain that. I can test this pretty easily. Just turn on all logging, run it again, and look at the dump. Haha, yes, it decoded it with the wrong length and decided that the next instruction is apparently an 8-bit add and decoded a bunch of total bullshit. Okay, that's the problem. Ooh. So what happened here? Oh, we forgot to add the read mod.rm. Which does mean that the arguments that came in are completely wrong. Great. Yes! That is the expected outcome. Whoop-de-doop. Let's actually break on this load 64, I guess. And make sure it is in fact doing the right thing. I don't know where these pointers come from. It's a little, so it's like slightly sketchy. But, okay, supposedly the second argument is within the CPU. Okay, where was I? This is actually seeming really sketchy to me, because this pointer is extremely different from either of these pointers. So let's just be sure. So where we were at is, I think, this modesty. Yeah. So edx to xmem 0. 0. This pointer seems quite wrong to me. I guess we could expect this Lee. Well, okay, let's step out of this function first. Wait. I think this doesn't clobber the entire R14 register or something. Yeah, that does actually seem likely. Alright, let's break here and, like, take a much closer look. So this is just save all the registers, push all the registers that are going to be a problem, and what's R11? That's the CPU pointer, okay. Yes, in fact. This little 3.6 here is wrong. I didn't manage to catch what R14 was before that, but it's probably like... that. I don't know where that came from, but we need to zero it. Hi, Soroka. This is about writing emulators, not really exactly about iOS. You see. If I tried to read 2 bytes, I'd get stupid. I'd get something wrong, and then that even wouldn't work. Okay, here's what I will do. Because if you load into the lower 32 bits, actually that might not be true. I don't know, this is too weird. Great, do we just explicitly zero it? I guess. And then I guess to avoid having to explicitly zero yet another register, we just reuse the same one. Slightly less ILP, but really, this isn't a hot path, I hope. What's up, Greedy? Why does your username say 996? Yeah, this is C. Well, actually, this right here, this is assembly language, but everything else is C. Okay, this might be an improvement, but wait. Okay. What this is supposed to do is add together R9. Oh my god, this should not be IP, this should be CPU. Fixed. Great, so this is going to be an improvement. I wonder why Twitch suggested 996. Because that refers to working from 9 a.m. to 9 p.m. 6 days a week. Yeah. Oh well. Twitch does let you change your username if you ever feel like that would be a good idea. To like 995 or something. Or 955, I don't know. No, you can actually change your whole username. They added this is like a new thing. Used to be you could just change the capitalization, but now you can change it. Thanks for following, by the way. Yeah, this is why my username used to be TBLODT, and I changed it for SEO reasons. I guess. I still don't know how to pronounce your name, Milo. Miloeu, but thanks for following anyway. Yes, Twitch SEO. It turned out to be really nice because when you sign up to become a Twitch affiliate, your emote prefix gets set and it can never be changed again. And so now my emote prefix is TBODT instead of TBLODT, and this is good. Milau. Okay, perfect. Milo? Oh, wait. Milo. Tell me if that's wrong. When did I start programming? Oh my god, 8 years ago. 8? No, 7. It's been a long journey. Oh, thank goodness the breakpoint's already there. I don't need to set it again. Actually, it's already there twice. Explicitly zeroed. Yay. Alright. This isn't supposed to still be 0, is it? Oh no, it is. Never mind. So add 0 to hex 30, and I think that's right. Yay! And then just R13. This, I'm going to, once I get into C code here, I'm going to check how valid this is. Be like, okay. Actually, I don't know what the address is that we're dealing with. Wait, I do. It's in EDX. That's correct! Now we just have to see if this is in the right order, which it is not. This is supposed to be the destination. But how hard can that be to fix? Thanks, Milo. Still a little bit of a problem. Oh well. Yeah, these are just the wrong one. The correct order is source comes first most of the time, unless this instruction is read into memory, in which case dest comes first. But that's it. We're good now. Maybe. We probably aren't. Everything is probably completely broken, but... Alright, we go run that. Go run that. We get the expected result. And now we have this, which is Eucomis. And this is about where I handed off to Matt. Where's Matt? Maybe he exists. Oh, well. So what's Eucomis? I need a browser tab, damn it. How's this? Hello. There we go. You're now on stream.
Where are you streaming now?
Yeah.
Am I on the stream?
Yes. Say
Hello,
hi.
stream.
Hello. So, I have Mavesty working. This is Matt. Matt, you want to introduce yourself?
Hi, I'm Matt.
Seems pretty good.
I code occasionally.
All right, I'm gonna
Not
commit
sure what else to
this.
say. Recently graduated, starting work soon.
Someone hire him. Actually, no, don't.
Just hire me, please.
Why do you keep saying hire me, please?
I don't know. It's funny.
I guess. All right, here's the code.
All right, so we've got gadgets now.
I have gadgets for x86, not for ARM. But that's good enough for now, right? Now you get to.
Is there a difference between which ones will run where? Is that for an x86 program versus an ARM program?
For iOS, for like x86 device versus everybody's computer, which is ARM 64 versus the architecture you're trying to run it on.
So is the iPhone going to be the ARM one,
Yeah,
and then the
yeah.
Linux one is going to be the x86 usually?
Right. So I guess it's your turn to try and figure out what the fuck I did.
Fantastic. Are you pushed on a branch somewhere?
I pushed it on master. Always the best branch to push things on. So the next instruction that it's hitting is unordered compare scalar single precision floating point values and set E flags. If you feel like working on this right now, you should go live and then I'll host you.
Okay. Should I wipe out my Alpine and start over?
No need.
Well, I mean, because I can't even run ish.
Oh.
There's probably something messed up with the file system.
Oh yeah, that. Well,
I'll move it.
before you wipe it out, definitely send it to me so I can try to debug it.
Okay, I'll move it to a different directory just so I have it.
Okay.
Um, what do I need? I need OBS.
Hmm?
And I need.
It seems like my microphone has been in slightly the wrong place this whole time. One moment.
Why is Edge not letting me window grab?
Edge?
Yeah, because it's hardware accelerated.
Why are you involving Edge in this?
I need to
It's
show the documentation.
11:45.
Just use
I don't
Chrome.
like.
It's basically
Yeah.
the same thing now.
Eh. Okay. I love the other.
You can alternatively just do a display capture and then nothing matters. Oh fuck, the build's broken. Every time I push something, the build breaks. Wait, what is this build? This is build... This is like almost literally the build I just did. Oh fuck. What's this? Invalid base plus index expression. Was it not supposed to have a B? This is probably something that just happens on Linux. Ew. Okay, I'll just take off the B and pray.
So uh,
Hmm? Is there a what?
okay, I think this will be working now.
What is it? Is this Chrome or something?
I'm trying to set up just the stream.
Hmm.
Okay, I think I'm sharing now.
There's some music.
It's my brother on the piano.
Ah.
Oh, I need to edit the description.
Alright, you're no longer hosting me, so I assume you figured something out.
Okay.
iSH SSC, very good. Let's click the raid button here. One moment.
Raid.
Very good.
Jinkies. You can't say that on Discord.
Raid button. Why do you not show up in the raid menu?
Do I need to allow you to raid me?
I hope not. Or maybe Twitch doesn't realize you're live or something.
Perhaps.
Let me refresh this. There you are. It still thinks you're playing Minecraft, but I'm sure that will eventually fix itself.
I can just.
There we go.
Okay. Okay, and I need to Fakesify.
I guess, yeah.